Welcome to our pre-calculus lesson on measurements of rotation. We're going to take those measurement of angle rotation you've learned in geometry, and we're going to make it a little bit more sophisticated. So most of your career in math, you have been measuring angles in Euclidean geometry, and that's where you measure a rotation. So what is the rotation from this blue ray to rotate to this green ray using this vertex as your point of rotation? And, you know, these angles could be open any which way, and they could be all over the place. But in pre-calculus, we want to grab those angles and we want to anchor them down. And that position that we anchor angles down in is called standard rotation. So notice I'm just rotating that angle. I'm not changing its measurement, and I'm placing it so one side of the angle is on the positive x-axis. And when you grab an angle and you orient it in such a way that one side is on the positive x-axis, we say that that angle is in standard position. Now, what does that mean for us? Well, that means really there are going to be two big changes in how we view angles. The first is the rotational direction matters. When we rotate counterclockwise, and I know you guys have rarely seen these analog clocks anymore, but counterclockwise means against the clock. So if we rotate this way, that direction is considered to be a positive rotation. So we might say that this angle is 120 degrees, and it's positive because it's going clockwise. But you could measure that exact same answer going clockwise. So instead of going counterclockwise or against the clock, you could go clockwise like this. You could go all the way around to there. That gets you from the same ray to the same ray. It takes us from the blue to the green. But since we went clockwise, this would be considered a negative angle. And so that angle we say is negative, and in this case it would be negative 240 degrees. By the way, notice what the absolute values of these two indicated angles add up to be. That is not coincidence. The second thing that is going to change about how we view angles is angles have more than one measurement now. This angle, this blue-green angle, could be considered 120 degrees, or it could be called negative 240 degrees. As a matter of fact, we don't even have to stop there. This angle right here, 120, we saw that we could call it 120 degrees. Why? We could also call that angle negative 240 degrees. And we could also say that that angle is, well, gosh, look at this. What if we took this, and to get from this red to that red, we went all the way back to the original red and over again. Why, gosh, that would be 360 plus 120. And so that would be, I'm terrible at writing this thing. That would be 480 degrees. So we don't even have to stop at 360 degrees. We can go around multiple times, over and over and over again, in both directions, positive and in negative directions. So there's a lot going on here that help us decide how to measure these angles. And there's more. Up till now in your high school, well, in your entire schooling career, we've been measuring in degrees. But degrees are very random. Degrees, they're based on the way the Babylonians divided a circle. Nobody quite knows why they said 360 degrees make up an entire rotation. It's fairly confusing. But in upper levels, in science, you might look at a revolution. Instead of looking at degrees, look at a revolution. How many times around the circle have you gone? Have you gone a full revolution, 360 degrees? Half a revolution, 180 degrees? A quarter of a revolution, that would be 90 degrees. Those are kind of sophisticated ways of measuring, but there's an even more deliberate way of measuring a circle, and it is called a radian. And I know you learned about these last year, but let's refresh ourselves. Here's the definition of a radian. It is the measure of the central angle of a circle formed when the arc is subtended by the circle's radius. And by golly, I'll bet you that clears up every question you had about what a radian actually is. I know, that's not clearing it up. Let's talk about this. Let's talk about radians, because radians are a very deliberate way of measuring a rotation in a circle. So again, here's the formal definition of a radian. And notice how close the word radian is to radius. So let's walk through this definition and see what it means. It's the measure of the central angle of a circle formed when the arc is subtended by the circle's radius. So I take a circle, I draw in the radius, and then I take that radius and I rotate it outside the circle. Now to subtend means to like flop over. It means that your radius is floppy. It's like a Twizzler. It can bend. And so when I take that radius and I subtend it, now remember, this radius is not rigid, it's floppy. And to subtend it means I'm going to bend it right around the circumference of the circle, and it looks like that radius might bend right there to that spot. That forms a central angle of the circle right here. And what I'm trying to tell you is that that central angle has the measure of 1 radian. This is terrible, right? 1 radian. Oh, geez, that's awful. So think of a radius as being a floppy Twizzler. To form a radian, you just take that radius and bend it around the circumference of a circle. Let me show you a better way of looking at a radius. A radian. Take a look at this. So I took the radius, I drew the circle, that's a radius. I'm now going to take that radius, rotate it outside the circle, subtend it or bend it, and then connect it to the center. That green angle is 1 radian. Notice it doesn't take a lot of radians to fill up the circle. As a matter of fact, how many radians do you think it takes to fill up the circle? Well, I think you're going to see it takes 2 pi radians to fill up a circle. Remember, the circumference of a circle is 2 pi times the radius. And since a radian comes from the radius, you can see that it would take 2 pi radiuses, or 2 pi radians, to completely surround the circle, to rotate around the circle. That is what a radian is. So, how many radians do you see in this picture? Well, right here, how many radians are there? There are pi radians. Here, we haven't got a full pi. Remember, pi would be half the circle. We've got pi halves radians. And here, we have 1 radius, 2 radiuses, 3. This would be 4 radians. That would be, I should probably mark it, that would be this angle right there. And again, we're allowed to go beyond 180 now. So the big idea of the day, and again, this just goes right along with what you learned last year, is that 180 degrees is the same as pi radians. Again, you know the full circle, the full 360, the entire circumference is 2 pi times the radius. So half the circle, 180, would just be 1 pi radius, or radian. Again, radian, radius, closely related. So, how do you use this to find some missing measurements? Well, let's do some practice here. I want to take 72 degrees, and I want to convert it into radians. And I want to take 72 degrees, I want to convert it into so many revolutions. How do we do that? Well, I know that 180 degrees is the same as pi radians. Again, 360 is 2 pi r, 180 would be 1 pi r. So I'm going to take that 72 degrees that I was given, and I'm going to multiply it by 1, because I'm not going to change the value, I'm just going to change the way it looks. Except, watch how smart I am with that 1. That big 1, I'm going to dress up. Now remember, 1 is any number over itself. 1 is 5 over 5. 1 is 12 over the quantity of 10 plus 2. As long as it's the same on top as it is on the bottom, it's 1. Watch how I dress up that 1. Ooh, did you see that? That was pretty cool. Hey, that was pretty cool. I mean, and you guys can rewind that and watch that again. It was worth seeing. But aren't pi radians the same as 180 degrees? They are the exact same. Look, it says so right here. 180 degrees is the exact same as pi radians. This is the number 1. Now, why did I put the radians on top and the degrees on the bottom? Because when I multiply these out, and when I analyze just the units, do you see the units of degrees cancels? And that gives me, well, actually, I think we could do a little bit more canceling here. I think that 72 and 180 share a common factor, don't they? I think they do. And if you do all the math on this, you end up getting 2/5 pi. Hint, the common factor they share is 36. 36 goes into 72 twice. 36 goes into 185 times. That's how I got 2 pi over 5. And it doesn't matter if you put the pi off to the side or up in the top. But that's how you get 2/5 pi radians. Let's talk about how we take the 72 degrees and convert it into revolutions. We know that 360 degrees is the same as 1 revolution. So if I take this 72 degrees times 1, but I dress up that 1 at, oh, there it is. Whoops, whoops. Whoops, what's this? I said 1 revolution is 365 degrees. I wonder why I said 365. I'll give you a hint. They believed that the Babylonians came up with the number 360 degrees in a circle because they knew it took the Earth 365 days to rotate around the sun. Yes, they knew the Earth rotated around the sun. Well, 365 does not have a lot of nice divisors, but there's a number close to 365 that does, and it's 360. Is that what the Babylonians were thinking? Well, we don't know. But anyways, you'll notice that we can go through here and we can say degrees cancel out, and we can find that common factor, and we can get that the answer in this case is, 4/5 of a revolution. 4/5 of a revolution. So that is one way you can use your clever big 1 to solve these problems. Let's take a look at one more example together. 11 pi over 12 radians is how many degrees? Well, I'm going to take 11 pi over 12 radians and I'm going to multiply it by 1. And what's that going to give me? Well, I'm going to dress that 1 up as, think about radians and degrees. What's your 1 going to look like? Boom! Well, now wait a minute. This time I put the degrees on top. Why? Well, because look at my units. I want the unit of radian to cancel. I want to be left with just degrees. Also notice that the pi's cancel. And now I can just do some basic math. I can take 11 divided by 12 and multiply it by 180. You may also recognize that 12 goes into 180. Oh gosh, how many times? 15 times. And that equals 165. Where is it? 165 degrees. So, tonight you have some homework problems, and some of them look just like this, some of them look a little bit different, but I want you to think about it and complete the homework. I will see you next in class period.